Hello all, and welcome back again. So I believe you have done the experiment which I asked you to do in the last video. And if yes, if you have done that, then we can move on with the observations. So let's discuss the observations of the previous experiment. So did you observe the outer planets doing a weird movement which repeated itself as I said in the last video after a period of time? And did that movement look like this? Like a kind of a Z or similar structure? So that movement is called as a retrograde. Ptolemy had seen this movement as a fault in Aristotle's model. And to take care of that, Ptolemy used the concept of the epicycles around a different to solve the model. But his solution created a new problem in itself. The problem was while doing the solution, he didn't consider the true motions of the bodies, but he considered the relative motions. Now, by true motions, I mean the real motions, how the planets are moving through the sky. And this motion, this retrograde, is a relative motion. It's not a true motion. It's not how it truly moves. And there is another thing. If Ptolemy was right, then we should see the same retrograde movement. Let's see this movement every time when retrograde happens. But do we see the same retrograde happening over and over again? No, we don't. And that's the another main problem. Now, if you look at these images, you can see that the retrogrades happened in 2003 and 2005 are in no way similar to each other, and same is the case with the retrogrades happened in 2014 and 2016. They also are in no way similar to each other, and that's the main fault. If if we were following the if the planets were following the Ptolemy's model, then let's say this is the retrograde which is happening, then this movement should repeat itself. But we can see here that these retrogrades are nowhere near to this movement, and that is how one can say that Ptolemy's model was wrong. And here, using these movements, one can prove that the heliocentric model is a better way to represent these motions. So now let's use the heliocentric model, and using that, one can prove that the motion is an illusion which is caused by the difference in the orbital motions of Earth and Mars around the Sun. So now if you look at this image, you can observe how the illusion is happening. So now let's do a small another experiment. And now let's say that this is a track, and the blue and red are two different cars, and you are sitting in the blue car and you are driving it, and the blue car is moving faster than the red car. So eventually you will overtake the red car. So when you are far away from the red car, you'll observe that the red car is moving in the forward direction, you are moving in the forward direction. As you get closer to the red car, you'll see that the red car now has started coming back towards you. Alright, and then as you overtake the car, you will find that now the red car is started has started going back away from you, and after some time you'll observe that now both the cars are moving in the same direction. So that's what we observe here. So when the Earth is closing on Mars, for the in the beginning we'll observe that Mars is moving towards the normal direction in which the stars move due to the rotation of the Earth. But then, as we close on the Mars, we'll observe that Mars has reversed its direction of motion, and now it's going backwards. opposite to in which direction it was going earlier. And as you overtake Mars after another few days, you'll observe that it has again turned its direction and now it is going in the same direction as it was going earlier. And that's the illusion we observe and call as retrograde. Now, it happens with every outer planets, and it is one of the many and main things which support the heliocentric model. Now, one might ask then from where the difference in the retrogrades come from. So now this difference can be incorporated with the use of the tilts of the orbits on which the planets are rotating, orbiting the sun. Now we assume that all the planets are orbiting the sun in the same plane, but that's not the case. If you look at this image, the blue orbit is the orbit on which Earth is moving, and the orange path is the orbit on which Mars is moving. And if you can see that there is a little bit angle, a tilt between the orbital planes of these two planets. So now Earth will overtake Mars at any point on this on these two orbits when both of the planets are at different positions on the orbits. And that's why there is this difference in the retrogrades at different retrogrades. The positions of these two planets are different, and that is why we observe different retrogrades happening. And now that's how we can say that the heliocentric model can be can explain the motion of planets in the solar system better than the geocentric model. Now one can use these relative motions of the outer planets, to calculate the orbital path and prove the heliocentric model true once again. So in the end, let's look at the models suggested by Ptolemy and Copernicus. So here, the red is the Mars and the stationary green is the Earth. So now that is how Ptolemy said that the planets are moving. They are orbiting a center on which is orbiting the Earth, and that's how they are getting the retrograde motion. These whitish starish things are the fixed stars. Now let's observe the one stated by Copernicus. So this is how Copernicus said that the planets are moving, the retrogrades are happening. So now I believe you are getting an idea what I said in the last few slides. So Earth is coming from behind, overtaking Mars, and then the illusion is happening, and that's the retrograde. So I believe you all had fun discussing this topic with me, and I will be posting a few more videos in as the time passes by. So stay tuned and thank you.